All right, I wanted to talk really quickly about what it would look like if we wanted to change the confidence level um, of our interval, right? So we still have these same values as the previous video. We've got our sample mean, sample size, and the population standard deviation. The difference now is that I want to compute a 99% confidence interval, right? So in our 95%, previously, I just went ahead and used 1.96 as our Z critical value. But I'm going to show you here what I actually did in order to figure out the Z critical value using the norm inverse function in Excel. So you remember that the Z critical value is the value such that the probability of a standard normal random variable falling between the negative version of this number and this number is the confidence level, right? So the probability of being between minus 1.96 and 1.96 is 95%. So what we can do to find that, remember that our norm inverse gives us the probability of falling below this value, right? By definition, it gives us the value or gives us the value such that the probability of falling below that value is whatever we put here. And our mean and standard deviation are because they are a standard normal random variable, right? So here, the value that we're looking at here is 1 minus the confidence level divided in half. Because we have that symmetry of the curve, remember that we were looking at in the Z value, the Z critical value, when we talked about it before, we're looking for the area between. Well, what we can actually also do is realize that the tail values each have the area of 1 minus the confidence level divided in half, right? Because the confidence level is what's in the middle. 1 minus the confidence level is out on each tail. And we need to divide that in half to find the value that is above on the right-hand side of the tail, right? So to find that on the right-hand side of the tail, we need to take 1 minus the confidence level divided by 2, which in this case, 1 minus the confidence level divided by 2 is 9.75, right? So the 1 minus the, sorry, I should put parentheses here. PEMDAS is important. 1 minus the confidence level is 0.05 divided by 2 is 0.975, right? So that's the value that's going to go here. And you can see that the Z critical value, when we compute it that way, is really, really, really close to that 1.96 rounded number, right? So let's do this again for 99% confidence interval. I'm going to go ahead and put parentheses here so that we know what we're doing, right? So our confidence level in this case is 9.99. We want 1 minus that value divided by 2, right? So we have this value out on the tail, right? And so the probability of being below that value is going to be the probability of being below 1 minus that value, right? Because we're finding the probability of being above this number. So we want this, right? So our point estimate is the same as above. Our Z critical value is the norm inverse of this guy, 0 and 1, right? The probability of being below whatever this function returns is 0.995. Right, so our Z critical value is 2.5758. So, round that to whatever you want. And our margin of error, as before, is the point estimate. Oh, nope, it is not the point estimate. That's the lower number bound. The margin of error is our Z critical value times the standard error, right, which was the population standard deviation divided by the square root of n. We see that this value is a little bit bigger, right? Because we are multiplying by a z critical value that's a little bit bigger. And we've got then our lower bound of our interval is 9.89 minus the margin of error, and our upper bound is 9.89 plus the margin of error, right? So you can see that this one's actually a little bit bigger, a little bit wider. And I think this goes to show that it is, because I think a natural question is, why would we use the 95 when we can use the 99? Why would we use the 99 when we can be, 99.999% confident? Because as these values get bigger and bigger, as our confidence level gets bigger and bigger, so does our interval, right? In order for there to be 100% confidence interval, that would actually be the entire number line, right? You would have to make an infinitely wide interval to be able to be 100% confident that it contains the mean. So keep that in mind. We're going to go through and work through a couple different values with different distributions, but that's what we're going for the confidence interval. We've been able to compute the 95 and the 99. And these are standard normal confidence intervals.